This plant has dozens of machines that turn rock and stone into cement, concrete's essential ingredient. This machine moves people and cars across some big water. The Super C-Class double-ended ferry does it best. A raging jet fuel fire burns up a plane in seconds. To put it out, you need a special firefighter with some reach, the Oshkosh Striker. Let's look inside these machines to see how they work. This is the St. Mary's cement plant on the Canadian shores of Lake Ontario. Cement is the essential ingredient in concrete. Concrete is basically sand and gravel. Cement is the glue that holds it all together. And plants like this one have to be able to make a lot of it, because we need a lot of it. The world uses about 3 billion tons of it every year. The recipe? Crush piano-sized rocks, blast dust through man-made tornadoes, and cook it into a molten lava. All to make a material that's built the world we know. It's the most versatile building material in the world. So this plant's machines run weeks on end, day and night, without ever stopping. Let's take a closer look. To make cement, you need to measure out some crushed limestone, sand, and iron, and cook it up in a big oven. The end result? Super powerful glue that's activated with water. The basic recipe for cement is simple enough. What's tough is making huge amounts real fast without making a mistake. One tiny error in the formula ruins the whole batch. So what makes limestone so special? Cement needs calcium. And limestone started out as the calcium-rich shells and skeletons of small prehistoric ocean dwellers. It's the calcium in cement that gives it properties necessary to help form concrete. And it's the cement plant's giant pestle and mortar that starts the rock crushing. Giant pieces of rock are dumped into it as the center cone sways back and forth to break it up. In seconds, this machine reduces a rock as big as your dining room table to chunks the size of a grapefruit. The trick to keeping this all going is a steady supply of rock. No way you could ever ship this stuff and stay in business. That would cost way too much. So for a cement plant, location is everything. This is the limestone quarry next door. When it runs dry, the whole shooting match has to pack up and move to a new location. To get at the limestone, it's hacked off layer by layer in an open pit. Explosives are packed into precision-drilled holes along the mine's leading edge. The charges are set off like dominoes, all of them detonating in less than a second. One blast frees up 50,000 tons, which will keep this crusher fed for up to 5 days. The chunks fall from the primary crusher onto a conveyor belt for further refinement. But the rock still has to go through 2 more crushers before it's reduced to a dust so fine that it could pass through your home coffee filter. Next step, the rocks are delivered to the hammer crusher. And it beats them into golf ball-sized chunks. Now, add iron and sand. The mix has to be perfect, so machines monitor it every second. They can adjust the mix on the fly or send warnings to a control room. Now, it's time for the final crusher. And it's a big one, more than 5 stories tall. The mixed rock is driven under 50-ton wheels that do the crushing. If the amount of rock gets too low, sensors tell the conveyors to pick up speed. A huge vacuum sucks up dust from the crusher and sends it to these hoppers. From there, the dust is screened for impurities and stored in one of the world's largest silos. Mix water with what's in here, and all you'll get is gray muck. This stuff is still just rock dust. To become cement, it has to be superheated, then mixed with more ingredients, on its way to becoming the ultimate construction glue. Heat is the critical catalyst in setting off a chemical chain reaction that turns the raw mix into the real thing. The stuff that hardens when mixed with water. For that to happen, you need to get the carbon dioxide out of the stone. And the best way to do it is to get things real hot, all the way to 1600 degrees Celsius. That's hotter than the core of an erupting volcano. It starts in this preheating tower. Heat from gas burners rises up through interconnected cones. Each one is 7 meters in diameter and 15 meters tall. The limestone powder swirls down through the rising heat, moving from one cone to the next, heating up as it goes. 5 cones later, it hits 900 degrees Celsius. And that's the magic number. At this temperature, it creates new bonds and frees carbon dioxide stored in the limestone. Next, you need to bond the dust back together by melting it in this kiln. At one end, a giant flamethrower that slides between 2 blast-proof doors. Fuel blows down its length and explodes into flames 10 meters long. Hundreds of air compressors stoke the fire with blasts of oxygen. Advanced thermal imaging cameras keep constant watch. Temperatures have to be kept steady to make sure the product is consistent. And that's just one of the problems maintaining a blaze this powerful in a kiln this big. You also got to stop it from clogging, twisting out of shape, or developing dangerous hotspots that could shut the whole thing down. To prevent backups, the kiln never stops turning. That action keeps the mix tumbling, like clothes in your dryer. And since it's designed with a downward slope, each rotation carries the mix a bit further. The twisting force is strongest near the motor and loses torque further out. So these support tires have a flexible inner ring that allows the outer section of the kiln to slip, making up for any lag in rotation and keeping everything turning together. The rings relieve pressure that builds up from the high torque twisting. Without them, the kiln would tear itself apart. By the time the mix reaches the other end, it's a scorching 1500 degrees Celsius. Machine-made lava. So the kiln has to be lined with ceramic blocks. Hundreds of thousands of them. They're tapered, so when you stack them together, they form a circle, supporting each other like an arch. Even with the blocks, the outside of the kiln can get dangerously hot. So technicians use infrared cameras to locate trouble. Problem spots get immediately blasted with cool air from massive fans. Even then, the heat and friction take their toll, and eventually turn blocks from this into this. When that happens, the kiln is shut down. It takes a full week for it to cool enough for maintenance crews to do the repairs. The bricks last for about 12 months each, giving the kiln enough time to make about 2 million tons of this material. It's called clinker, and it's what you get from all that cooking. Basically, dust that's been partially melted back into rock. The clinker is cooled on vibrating grates in a building connected to the kiln. The material is then picked up by a conveyor and sent on its way to be mixed with the final ingredient, gypsum. It slows the chemical reaction that begins the moment you add water to cement. Both gypsum and clinker are put on precision-controlled conveyors. 95% clinker, 5% gypsum, and fed straight into a rollerball mill. Inside, steel balls pound everything into microscopic dust. By the time these machines are done, the powder is so fine that compressed air simply blows the finished product up these pipes and into storage silos, ready for pickup. Just 3 hours ago, this rock was part of the Earth's crust. Now, thanks to the machines in this cement plant, it's ready to build bridges, roads, buildings, and pretty much everything else you see around you. This is a Super C-Class ferry, a vital transportation cog working the coast of British Columbia, Canada. With way too much water for a bridge between the mainland and nearly 1 million residents who live on these islands, ferries are the only practical way to move thousands of people, their vehicles, and countless goods back and forth every day. This 160-meter, 10,000-ton ship can haul almost 2,000 passengers, 370 cars, and 32 tractor-trailers at the same time, making it and its 2 sister ships the largest double-ended ferries in the world. And that means more than having 2 doors. You need 2 wheelhouses, 2 propellers, 2 rudders, and 4 giant diesel engines. And then you need some advanced engineering and safety systems to keep it all floating. Let's see how it works. A double-ended ferry like the Coastal Celebration is basically a floating bridge powered by huge engines. You just drive in one end and out the other. This allows the ferry to load and unload all these cars and trucks in as little as 20 minutes. But this design creates a few problems. Having propellers on both ends is great for getting in and out of port quick, but how do you get them to work together? First up, propulsion. These monster engines crank up a pair of electric generators, powerful enough to supply a constant source of electricity to almost 20,000 homes. All of this energy flows to giant electric motors, one for each propeller. To change direction, just cut off power to one and send it to the other. The machine's propellers have a variable pitch mechanism that gives them total maneuverability. So when not in use, the blades turn and tuck into a streamlined position. That's basically how you make a ship with no front and no back. But the Super C ferries are so big and powerful, they need special engineering to make sure the parts can stand up to the pressure. Each motor spins the propellers with over 21,000 horsepower. That's the equivalent of 600 standard outboard motors, made all the more efficient by a flex cam system that adjusts each of the engine's pistons hundreds of times every minute. All that power puts a lot of strain on the shafts that connect the motors to the propellers. So special oil-filled rings support the shafts and prevent warping or twisting from all that torque. One of the ship's enormous propellers is spinning on the other side of this steel wall, and it's got problems of its own to deal with. One of the biggest is a destructive form of erosion unique to marine vessels. Props this big create lots of bubbles and incredible amounts of water pressure. That's great for thrust and propulsion, but the action is also strong enough to compress air bubbles so much that they superheat and explode. It's a phenomenon called cavitation, and it would chew through the blades if they weren't made from a specially designed alloy that ensures long-term durability. The Super C's designers put a lot of thought into safeguarding mechanical parts on these ships. But what about the passengers? Fire is always a huge concern for ships at sea. Select crew are trained as firefighters, and each ferry has its own team. But if fire breaks out on a ship, you have very little time to stop it before it gets out of control. So in keeping with all the other bells and whistles on this machine, they installed a unique fire protection technology that knocks out blazes before they can spread. Their system combines the suppressing strength of water with a knockout punch of anti-fire gases without risk to passengers or crew. The Super C-Class ferries use a high fog system that can put out just about anything in under 5 seconds. And it does it with 90% less water than a traditional sprinkler system. Nozzles are placed throughout the ship in key areas. Water is pressurized in this tank, then blasted through the nozzles that atomize it. The resulting mist blankets a large area, while pressure forces the fog down to the heart of the blaze. The key to its success is reducing the temperature of the fire and knocking it out as quickly as possible. The system can be activated by temperature gauges, smoke alarms, or manually. There's plenty of other things to keep a crew occupied out here, like other boats. When you're this big, you sure don't want to hit them or knock them over with a big wake. So the hull is designed with wakeless technology. The wide top section floats on a narrow underwater section, perfect for cutting through the water. And even when cruising at 25 knots, it produces almost no wake. Up on the bridge, a state-of-the-art navigation system helps captains counter tides and currents, see through thick fogs, and make sure the ship arrives on time. They also have an autopilot system that's guided by GPS to help locate other ships. And when they're cutting through narrow channels between islands, there's a lot on the line. One wrong move in these busy waters, and the ferry could run aground. So one lucky crew member stands by, ready to drop the machine's giant emergency brake, the anchor. If the engine fails, it's dropped immediately, bringing everything to a quick stop. But what if things do go really wrong and the ship has to be evacuated? Where are all the lifeboats? They're safe, sound, and out of sight. These lifesavers are inflatable. In the unlikely event of an emergency, slides blast out the side of the ship and passengers take a 5-story ride. Massive self-inflating lifeboats wait at the end of the slide. Designed specifically for ferries, it's the fastest evacuation system ever made. And it leaves passengers free to enjoy their crossing and the view from high above the water, while saving a multi-billion-dollar expense of having to build a bridge over 40 kilometers of ocean. Besides, who wants to drive over a static bridge when you can slide onto a moving one that does the work for you? This is an Oshkosh Striker, a custom-built firefighting machine designed to protect airports and passengers around the world. If a plane crashes out here, the Striker's gotta respond in seconds, protect firefighters from jet fuel blazes, and put the fire out fast, even if there isn't a hydrant in sight. Toronto, Canada's Pearson International and its 5 runways are spread out over 18 square kilometers of uneven terrain. It handles over 30 million passengers and almost 500,000 flights every year. It's a great place to see the Striker in action and to get a sense of the challenges this machine has to overcome. Let's see how it works. To fight fires out here, you need superior firepower, extreme mobility, rock-solid stability, and total visibility. Fires fed by jet fuel pack a lot of punch, so you need more than regular lines and hoses to fight them. The Striker comes with joystick-controlled roof and bumper turrets that can attack flames from over 60 meters away. A design feature that is as efficient as it is powerful, thanks to the machine's high-powered water pump and its impeller. Water is sucked into the pump, then it hits the spinning impeller. Enormous water pressure is created by centrifugal force from the spinning action of the curved blades. Design features that allow a single firefighter to control a blaze. And if burning fuel ever threatens the Striker, it has 5 undercarriage nozzles to create a wet safety area on the ground around it. The turrets are fed by an onboard tank that carries 17,000 liters of water. Enough to fill about 25 queen-sized waterbeds. And all that extra weight has to be moved fast. Jet fuel fires can rage at over 1,000 degrees Celsius, so they can burn through a fuselage in minutes. So every second counts. To reach crash sites fast, these machines need amazing speed and handling. Easier said than done when you're moving over 50 tons of aluminum and rubber. Speed starts with a 950 horsepower engine that lets the Striker hit 85 kilometers an hour in under 35 seconds. Onboard GPS plots the quickest path to the accident, automatically directing the Striker around busy airport roads and runways. That takes care of speed. Now you have to control it. Firefighters are always at risk racing to emergencies, so traction and stability are critical. A fully independent suspension lets individual wheels ride as high as they need to. All-wheel turning helps the operator with precision. The Striker can also deflate its tires to increase traction if it has to go off-road. And big clearances mean it won't get hung up on the way. A massive wraparound cab that comes with 80 square feet of glass and total panoramic views ensure drivers never get blindsided. Hand lines also allow firefighters to get out and attack the blaze from different angles. With tools like these, the Striker can put out almost anything in record time. And it needs to. When a plane goes down, the passengers and crew have only a few moments to escape. Fortunately, with the Oshkosh Striker on the scene, they've got a fighting chance.